Hey, this is OXDF, and today we're doing Advent of Code 2023, Day 16, The Floor Will Be Lava. Awesome name. Let's check out the prompt. Normal story stuff. Basically, we're going to have a it's grid, everything's grid this year, full of empty spaces, which are the dots, and mirrors, which are all the other things. And so we're going to have a light beam come in on the top right corner, moving to the right. So it's going to start off grid and kind of move this way. And when you go through an empty space, you just keep going straight. When you hit one of the mirrors that are tilted on an angle, you make a 90-degree turn. So if you're coming to the right, you're going to go down. If you're coming from the left, you're going to go up. If you're coming from the up, you're going to go left. Coming from up, you're coming from the down, going up, you're going to go left. I think I may have said something wrong there, but I think you can probably follow. The interesting ones are these bars. If you come into they call the pointy edge, that makes sense. If you're coming up into a vertical bar, or if you're coming left or right, or down, if you're coming left or right into a horizontal bar, you just keep going straight, no change. But if you hit one of these things head on, so your beam hit, you're coming to the right and you hit this beam, then it's going to split, and it's going to go up and down out of there. Likewise, if it comes up into this one or down into this one, it's going to go left and right out of it. So basically, we need to run that beam. If it goes off the edge, it just goes off the edge, and it's gone. We need to run that beam through till it's done, and figure out basically how many spots have the beam passing through it. So we will grab this example input. We'll jump over here, and I call my Gende script. There will be a link. There's a link in the description to my repo with all the code, and it includes the script, but it just pulls the input for me and generates me a stub to work with. And I'll make this example.txt as well. Nice. We can look at the input real quick. It's 110 lines. I don't know if it's square, but it's about the same size. It's not super densely populated, but there's a lot of mirrors there. Yeah, we can handle it. Let's go ahead and write some code. We're going to approach this as a breadth first. I guess it's not a search, it's a fill. A breadth first fill. We're going to start with a grid, as we always do. I want to make sure to get rid of new lines here, so I'm going to say l.strip for L in there. So now we don't want any new lines. That'll be good. So what are we going to do? We're going to have to create a queue. So let's see. Under here, we'll say from collections import deck, import deck. And then we'll say scene equals set. So we'll track where we've been. We'll say queue equals deck. And we're going to start that with a single state, where that state is our row, our column, our dr, our dc. So we start off at 0 row. We're going to start ourselves off the grid at -1. We will be moving no rows. We're moving to the right. So rows are not changing and columns are increasing by 1. And that should be our initial state. I wonder if we want to start on the grid, start at the first spot, if we want to start off and move into it. I'm not sure about. We're going to keep that in mind as we move, because we might want to change that. So we'll say while typing q. So what are we going to do? We're going to pop off, say rc dr dc equals q dot pop left. And again, it doesn't matter. I could pop right as long as I'm appending to one end and popping off the other. In fact, in this case, it doesn't even matter, because the order doesn't matter. I could do a stack or a queue here. It doesn't matter. So the first thing we're going to do is going to move. So we will say r plus equals dr, c plus equals dc. We could, if we started on the map, what we could do is we could not move. We could add this thing, check our state, blah, 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 and then move it. And then come down and do the move checks after and see if we want to move. I don't think it matters. I think we could do it either way. But we do need to do a check here. So if let's see. If we go off the map, we want to fail, right? So I think it's easier to write this as if we're on the map. So if not, let's see, 0 is less than or equal to r less than. I'm just going to go ahead and create some height. Height equals len grid, width equals len grid, and we did notice it was a square, so we can just do grid 0. So now we can say less than or equal to height and 0 is less than or equal to C is less than width. So basically, if we're off bound, we're just going to continue. We've left the map. We don't care. Dump this one. We don't do anything. So that's cool. Now we need to turn. Well, we need to turn. So let's say how we're gonna handle that. So we will say match grid RC, and then we can do a case. So I'm gonna pull up. I'm gonna take this. Let's see. I'm gonna move this on the other screen, so you won't see it, but I will, so I can have this list in front of me. Where are we? Okay. So if we have the case of an empty space, then we are going to do nothing. We don't change at all. So let's not deal with that one. Okay, so if we have a case of the mirror like this, now I'm just going to think this out. So if our current D's, dr and dc, is 0, 1, so that means we are moving to the right. Then when we hit this thing, we are going to go up. So we're going to be now we're going to be -1 for our dr and 0. And I always forget, this is always tricky because we're doing a 0 at the top left, so -1 is up. Now similarly, if we're coming down, so if we're let's see, that's 1. Now I guess we'll say if we're coming down, so that'd be 1, 0. Do we need another? Whoa! What did I do? Don't do that. I guess we need to do this. We might we'll get rid of these comments, I guess. So if we're coming down, so that would be 1, 0. We're going to go to, now we're going to be going to the left. So we're going to be saying 0, -1. If we're coming up, so that means our -1, 0. We're going to hit this thing. We're going to end up going right. So we're going to go to 0, 1. And what we're going to notice actually is that we don't even need this line, right? We can go here and do that. And so I bet you it's the same here. So if we're coming up, we're going to hit it and go, did I get that right? If we're coming, yeah, okay. If we're coming up, we're going to cut that and we're going to go this way. So in this case, what we need to do is no matter what, we are going to take -dr, so dr dc equals -dr, -dc, just like that. Hopefully that makes sense based on this diagram. Similarly, I think we're going to have a similar thing here. If we are coming, let's say we're going to the right again. So if we're going to the right into this one, we're going to go down. So this is going to be 1, 0. And if we're coming, if we are going down, we're going to end up going right. So that's going to go both ways. And same thing here. If we are going 0, -1, so we're coming in this way, we're going to end up going up. So we're going to say 1, -1, 0, and this is, and again, this might be slightly tricky because we're in row column, so top left orientation. So that means up is, we gotta remember, up is negative. So we're going left, we're gonna go up. We're going up, we're gonna go left. So this is gonna be the same thing, except for this time we're not gonna negate it. dr dc equals dr dc. Sweet. All right, next case is if we hit a pipe. Now, if we hit this pipe, if we're changing, so if dc is not equal to 0, and we're making the assumption here that DC, either one of dc and dr is always 0. So if our columns is changing, yeah, that's what we want. Then we're gonna do, we need two things. So what we better actually do here is do like next dirs equals that, and now we can say next dirs dot append that. And we'll do the same thing here, next dirs dot append. And the reason I'm doing that is because we're gonna have to deal with multiple next dirs, and I better make that a tuple or I will get a mess here. It's very important to add tuples to your thing and not not you add them individually. Although I think append there would throw an error for trying to append two things. So okay, if DC is not equal to 0, pass this for a second. We'll come back to it. I guess we're going to say if DC, okay, if DC equals 0, then next dirs dot append dr DC. We don't change it all, right? If we're hit a thing, but we're changing in the rows, great, we don't do anything. But else, next there's dot extend. I'm going to give it a list of tuples. So there's going to be two tuples coming out of that, right? The first one, so if we hit this thing, we need the dr. We're going to start changing in rows. So we're going to be 1, 0, and we're going to be -1, 0. Now, I think that covers that. Case dash. If dr equals 0, it's going to look very similar. Next, there's dot extend append dr dc. Else, next there's dot extend, and extend basically takes a list of things and just adds them each to the list. So that's why we're doing that. There, and this time now we're going to come out of this going left and right. So it's going to be 0, 1 and 0, -1. Let's see, what else have we not done yet? Okay, I think that's everything except for we do need to add in what happens now if we hit the dot. I guess we'll do this. We can say next, there's, grab this. That. So if we hit the dot, we just want to keep going. And then I'm going to give it a base case here. For anything else, we're going to assert false. That'll just make sure we don't hit something else. If we hit something else, this is going to throw an error and we'll know about it. We can debug. So now that we've handled our directions, which is quite a bit of that. Let's see, are we there? Okay. Now we're going to say for dr dc in next stirs. So we're going to, for each of those things, if rc dr dc, yep, not in scene. So if we have, if the next thing is new, we'll do scene dot add, grab you, and we'll do q dot append like that. I think we're good there. Let's see. Let's just run this and see what happens. Python day 16 example.txt. Wow, we don't like len of grid 0 built in. Built-in function that has no. All right, it helps if we actually call strip there. All right, that's fine. We hit assert false. I think I can add a message here, right? Unknown char. What are we doing here? Grid RC. Is that going to work? We'll see in a second. Did I grab the wrong example? I grabbed the wrong example dot. Let's see. This is why we put that in there, because it catches errors. So put that in here. It's really simple to catch. We've got something. It doesn't look as long as we gotta get to 46, I believe it said. So I'm not sure we're getting it right quite yet, but let's see. So I guess we can't just look at scene because we might have like two in the same tile going different directions. This is definitely not 46 long though. We can look at the length of that. 17, definitely not long enough. So what are we going to do here? Let's just glance through here for any obvious mistakes. Let's see. Nothing comes out of me as crazy. So let's go ahead and we'll print. We're going to go classic print debugging, print rc dr dc, and let's take a look at the map as we do it. So we can now, this is where we pull the example back up on here and say, what are we doing? So we're going to 0, 0, we go to 0, 1, we go to, from 0, 1, we're going to come out in both directions, that makes sense. Then we go to 1, 1, that's good. Then we go to 2, 1, 3, 1, all the way down to 7, 1, where we're going to then move right and left. Cool. 7, 2 looks good. 7, 0 looks good. 7, 3 looks good. 7, 4 is, I don't think, right. We're hitting our first diagonal mirror, and that it looks like, so we go from, I think we didn't flip. That looks like the problem. Let's see. Yeah, so we are negating dr and dc, but we're not flipping them. We were supposed to flip them. So I think we need to do this, and we need to do this. That looks better. Now but that's too big, but that's okay because we don't. Scene is not quite right. So we want to do. We can do like visited equals r comma c for r comma c comma underscore in scene. And then we just need to make this a set. Now we want length visited 46. That's better. Awesome. Okay, let's see what happens if we run on our input. We get an answer. Let's get rid of our print here. We don't need that. Where are you? Making things ugly. Perfect. 6921. You all, of course, want the glory of seeing this enter and get a star. Sweet. I'm going to pause and read this. Okay, so all they want us to do is, the goal is to energize as many tiles as possible, and we don't have to start on the top, on the left, top right corner, going in right. We can go from any row, any edge, so if we're on the bottom, we're coming up. If we're on the top, we're going down, any edge coming in. So I think all we have to do is change this into a function. So first thing we do, let's get part one still working, but make it a function. So I'm going to grab everything here. Def count powered RC DR DC, which we will type hint those because it's smart, because it's good to do. Int and int, and we will return an int, and we'll paste all of this. Tab that over. So we will not need you anymore. Let's pull this out. So part one is going to be count powered of, don't need a tuple, just need of that. I'm going to pull, no, we can leave that. Well, yeah, let's pull this out. It doesn't feel like we need to define it every time. Sure, that'll work. So now we're going to start with RCDRDC, and we're going to do all this same stuff here, and we don't need to, we can just return len of that. So actually, let's see if that works. That still gives us the right answer. Okay, so we have functionized part one. So now, in theory, we should be able to do part two is equal to 0. We'll say for r in len, len height, because we have that calculation. And so we can say part two equals max of part two, comma, count powered. And now what's our position going to be? Well, the r is going to be r. The c is going to be -1 to be off there. The direction is not dr0. So we're going to go down the rows. So we're doing the left side here. So we're going to be column -1, and we're going to be moving to the right like that. We also need to do the same thing, but coming in the other side. So in this case, r will still be r. The column will be width, and the direction will be -1. And then we can do for c in leng width, part two equals max, part two, comma, count powered. And now this time we're going to go across the different columns. So we can start with r of -1, c of c. We are moving down one and that. And then do the same thing, except for we're going to start with, still going to be at r of, nope, this time we're going to be r of height column. And now we're going to be moving down like that. And after that loop, we should have we will come in off each edge and keeping the max each time. And so if we run this on the example, ooh, we don't like that. Not len height, range height. That makes more sense. We don't len an int. We already saved that. 51. which is the example they gave us. So let's input. Ooh, is it gonna be slow? Nope, not slow. I mean, slightly slow. We can tell it hung for a second, but not bad. Sweet. This was a fun one. I like this. This is nothing, not too hard. Just sort of, you got to picture the problem and figure out how to handle it. This is something, one of the skills I've picked up doing Advent of Code is this whole breadth first search / fill. It's not something I had learned previously in doing this and sort of studying other people's answers. And in the after, it's a cool skill to have, and it's a great way to handle how do I process these things. I would have gone to recursion in the past, and recursion would be fine, I think, but it could get kind of intense, and this works just much easier. So I'm gonna call it here. Thanks for hanging out with me today. I will talk to you tomorrow. Bye.